Hi, I'm Matt Harrington. I'm an EFCO field service representative. I've been on hundreds of jobs over the years, and the number one question I'm asked on wall jobs is how fast can we pour the wall? My response that nobody knows the definite answer to is how fast is the concrete going to set up? Today, a local contractor has agreed to let us collect test piles and monitor their pour. I will collect a test pile from every truck and demonstrate how to monitor the test piles and maintain a safe rate of pour. The ACI pour rates provide a good estimate of how fast to pour. However, I have observed situations where concrete did not set up as expected, and even though the pour rate was followed, accidents still occurred. Many factors can contribute to the problem, such as sudden drops in air temperatures with the seasonal changes, which can affect the aggregate temperatures or possibly a batch of concrete with improper additive amounts. As a result, I've come up with this set rate chart to supplement the pour rate chart to help prevent exceeding the allowable pour pressure of any given forming system. To be clear, this method is not yet supported by ACI or any other governing bodies yet. This method is not intended to replace the ACI pour rates, but should be used in conjunction with it. Most importantly, the set rate chart method provides an excellent indication of how quickly the concrete is setting up inside the wall and allows you to approximate the actual pour pressure and whether or not you should slow down your pour rate or pause your pour. The set rate chart is based on collecting test piles of concrete from each truck and recording the time and height of the lift inside the form. The set rate chart method is good for every type of concrete and is independent of admixtures, slump, concrete temperature, air temperature, mixed design, concrete type, and any other variable. The same concrete going into the wall is the same concrete being collected for the test piles. In addition, the test piles can be tested safely on the ground as opposed to trying to handle a 20-foot piece of rebar up in the air on the scaffold to test the firmness of the concrete. Once you start your pour, you'll place 1 to 2 shovelfuls of concrete on the ground to monitor the set rate of the concrete. For best results, I suggest placing your test piles on a sheet of plastic that you can fold over and keep covered to prevent loss of moisture. Another option would be to place your test piles in an airtight bag or even a small bucket for SCC or other loose type mixtures. Make sure to record the time and height of the lift inside the form. As additional trucks deliver concrete, continue to monitor each pile of concrete to make sure it's setting up at the expected rate. To determine if your pour rate is not exceeding the pressure capacity of the form, you'll need to identify which concrete pile has set up sufficiently to hold its own weight. Concrete is supporting its own weight when your thumb can make an indentation of 30 millimeters or 1 3/16 of an inch. Also, if you stab your test pile with a shovel and it does not slump over, you know your concrete's setting up properly. Once you've identified how much concrete in the wall has set up, you then go to the set rate chart. First, you'll move up the vertical axis to the height of the set concrete. From there, draw a straight horizontal line across to the design strength of the forming system. At that intersection, go straight down to find the maximum height that your pour should be at. Compare this height with the actual height of the concrete in the wall. Now you have a great indication of whether or not you are within the allowable pour pressure of the form, avoiding any pillowing or even worse, failure. Pile 12 is 40 minutes old and is not set up yet. I can push my thumb in about 2 inches. Pile 13 is not set up at all. Pile number 11 has set up and equates to 14 foot 6 inches of concrete in the wall. This indicates that 14 foot 6 inches of concrete has set up in the wall. For this project, the forms are rated for 1400 PSF, which means that they can hold 9.3 feet of liquid concrete. Now we go to the set chart and find 14 foot 6 inches on the left. Follow the chart over to 1400 PSF and then go down. We can see that the max height of concrete in the form should not exceed 24 feet. If there is more than 24 feet, the chart indicates that we've exceeded the allowable pour pressure and need to slow down the pour. If there is less than 24 feet, the chart indicates that we can continue pouring concrete into the wall without exceeding the allowable pour pressure. If the concrete piles are not setting up as quickly as expected, the person or people collecting the test piles know that the concrete in the form is also not setting up as expected. You can then slow down your pour or even pause your pour until the concrete has sufficiently started to set up. The set rate method allows you to see if the concrete is in fact setting up and the allowable pour pressure is not being exceeded.